Okay, so now moving on to the definition of resistance in Ohm's law. Now, the flow of charge or current is proportional to the voltage. So if I have more voltage, I have more current. It's proportional to the voltage. That tends to make sense because if a battery provides a greater voltage or a greater potential difference, it provides more. Remember what voltage is. Voltage is energy per charge, so it provides more energy to the electrons. Thus, there is a greater flow of charge or a greater flow of current. So our current then is proportional, let's write this mathematically, to our potential. And Ohm's law describes this relationship based on the resistance. And it defines the resistance as being the change in potential over the current. Right? For a material, if R is big, then a greater potential or a greater voltage. Often I'll write V just without the delta, but it's implied that it's the potential difference. And on a battery, that's the potential difference between the two terminals on the battery. All right, but I'll just write it as a V. It requires a greater voltage to produce the same current. So a battery, for example, will produce a current in one resistor, but if you increase that resistor in order to keep the same current, you have to increase the voltage. As we said before, resistors, they resist the flow of electricity. They resist the flow of electricity. So, so if you want to push electricity through something that's going to resist it, you're going to be required to put in a greater potential, a greater amount of energy. The unit for resistor is the ohm, and the abbreviation for that is the Greek letter omega. Ohm's law is usually written in this way, not as R equals V over I, but V is equal to I times R. It's a good basic definition for Ohm's law. You can try this quick test. This is just based on the definition of Ohm's law and on the definition of current. Now, Ohm's law applies for most materials in which the resistance is constant over a wide range of V and I, and we will call these materials that obey Ohm's law, we call them ohmic. So materials that follow Ohm's law are called ohmic. For non-ohmic materials, though, the resistance of the material might change. So, for example, with an ohmic device, I have something like this. Now, I know that V is equal to IR, so I is equal to V over R. So if I plot this, my slope of this graph is going to be 1 over R. So I can find the resistance just by plotting the I versus V or V versus I, however it may be. And then you can take the slope of the graph. And you'll have to do this in lab. However, if I have a non-ohmic device, it has something that is not linear when you plot the I versus V, the current versus the potential difference. And it'll look like this, for example, right? Where the resistance can either go up or down depending upon what the current and our voltage are. We're not going to deal with non-ohmic devices, but diodes are one type of non-ohmic device. And if you go on and you take an upper level circuits course, you'll learn about diodes and other devices that are not ohmic. Resistors, most resistors, in fact, are ohmic, so that as the the voltage increases, the current increases by the same amount. For a diode, the resistance of a diode is small for current in one direction, and then very large for current in the opposite direction. So it basically acts as a gate or a valve for electricity, only allowing electric current to flow in one direction. Because when current tries to flow in the wrong direction, the resistance goes very, very high and doesn't allow that electricity to go in that direction. All right, so ohmic devices follow Ohm's law. Non-ohmic devices do not follow Ohm's law. Let's try this quick test. Let's see, I have a video I want you to watch. This is about resistors. I'm not sure if it's this video, but I have another video. You can watch it here. It's about resistors. And we will pause there.